Okay, and we're live with another episode of The Focal Thought. And my guest today is Michael Rocha. Mike, how are you today?
I'm good, Crichton. How are you doing?
Good, good. Thanks so much for coming on this podcast as my guest. I'm really excited about this. So, Mike, you're actually currently a senior solutions architect with cloud advisory and intelligent automation. You've got like vast experience in the field of computers. Currently, you're doing sort of IT consulting with cloud strategy and implementation, or you're working with complex systems architecture, multi-cloud, and complex integration. You're a big fan of design thinking, human-centered design, and you've won you're a recipient of the Outstanding Technical Achievement Award. The first question I want to ask you is, growing up, the family always regarded you as a computer wizard. So why was that?
Yeah, that's a good question. Yeah, okay. Um, so I think like when I was very young, I sort of, had a tendency to sort of, take things apart. I was very curious about, the way things worked. And that sort of, translated while I was growing up into an interest in technology as such. And I was fortunate because I think when I was in about class 10, so I would have been about 14 or 15 when I got my first home computer. And that at that point of time, it was you didn't really have. I mean, we were it was way beyond the PC age, right? It was this I'm talking about was about in the 1980s or so. So the personal computer as we know it today was not really I would say invented then. It was still being invented, and I think the first releases of the Apple Mac had just come in. You had the Apple Mac 1, I think, and the Apple Mac 2, which had just come in. And I actually was fortunate because I got my hands on a Sinclair ZX Spectrum, which was more of a home computer that you just plug into your TV and you can connect it. It came with an integrated keyboard, and you could connect joysticks to it. You had a tape recorder where you actually stored all your programs, and you had a manual which sort of taught you how to do basic programming. So that's where I sort of started. And I would do this more as a hobby because in terms of qualifications, I was actually more on the accounting and commerce side. So I would
Oh,
do
really?
this
Okay.
more as a hobby. Yeah, yeah. So I started doing this more as a hobby at home. And then what happened was actually while I was studying my bachelor's of commerce in college, they had a computer center. And these in those days what would happen is every individual who was trying to learn something in computers, whether it was a programming language or they were doing a course somewhere, they didn't have access to computers in their at their home. So they had to go out to a place where they could sort of rent out a certain number of hours or minutes and sit on those computers. So there was a computer center in the college where I was studying, and they were looking for volunteers. So essentially, what a volunteer would do was he would just manage the computer center. He would make sure that, okay, when a person came in, he got his time slot. When he finished at his time slot, you would go there and tell him, okay, your time's up. You've got to release the machine so the next person can use it. That was actually the most difficult part of the job, trying to get people to sort of give up the machine once they got hold of it. Yeah, but so and I was sort of involved in coordinating all of this. And while I was doing this, there were people who got stuck. They wrote maybe a 500 line program and they didn't know what happened. It wasn't running. So I would try and help them out. I would sort of sit with them, debug the code that they written. And while I was doing this, I said, okay, this is something that really interests me. And that computer center itself would have they had some courses which was which were conducted in the evenings. There had people who came in externally and they were conducting these courses for us. So I decided to sign up for some of these courses, and then I sort of discovered, okay, I had a flair for programming. And that's when it sort of really took off, and it was something that really interested me. I was passionate about it. So luckily for me, I sort of, I would say, at a young age, I found my what they call Ikigai now. I sort of found it at a young age. It sort of it's still what inspires me, right, to get up in the morning and go to work. It's not um, I don't think of it as work. I think of it more as, okay, this is just an extension of something that I love doing. So that's I think a lot of words, but in essence, that's sort of what happened with me. And I think in the family, people saw this and they were like, okay, whenever anyone in the family had a problem with their computers, they would say, hey, Mike, can you come and have a look at this? This is not working, or that's not working. And that's how I sort of, from a family perspective, people began to sort of recognize that, okay, I had this sort of technical bent of mind.
Correct. Yeah. And the reason I asked that is because the family did speak highly of you in terms of being a computer wizard. And it's very easy to say that maybe because they didn't know about computers, they just it looked like you were a wizard. But back then these machines were crude. It was sort of the early stages of programming with languages like BASIC. And really, you really had to know your stuff to sort of be comfortable with the machines, right? Because it wasn't sort of plug and play and user friendly like it is nowadays. Like you were almost sort of helping with the mechanics of the machine while using the machine, right? I remember sort of trying to, play a game, but you had to sort of write the game first and load it up, and only then it would play, right? In the early days.
Yes. So yeah. Because in those days, actually, when I first started off, I mean, the first thing that you didn't have was, the whole graphical user interface, right? So today we are all used to seeing a graphical user interface, whether it's on our phones or on our laptops. I mean, we can't imagine a computer without a mouse, right? Or some sort of pointing device or touch screen, right? But in those days, it was all, typically just, green screen. It was what we call green screen. So it was almost like a terminal, right? You just had to type commands to get things going, right? You didn't really have this sort of flexibility of point and click kind of. So that came much later. That came, I think, in the mid 80s when Microsoft released Windows 3.0 and then 3.11, and it started getting really popular in the 90s, right? When you had Windows 95 and then Windows 2000, Windows 7, Windows 8. So today we don't see that sort of everything's abstracted from us, so we don't get into the guts of the machine, as we say, right? And that abstraction has now become even more with cloud, right? I mean, you just, like, for example, if you use something like Box or Dropbox, you just take your files and you drop them there. You don't bother about where it's being stored. Is there a disk somewhere where my files are lying? You don't bother about that, right? It's all become very very abstracted from the end user. So you don't see a lot of that complexity because it's all sort of taken care of in the background. And I guess it's going to evolve even further, right? So as things progress in computing, you do see that there are more and more levels of abstraction being built, and a lot of the complexity is hidden from the end user.
Correct. It's akin to, I guess, if you're trying to, turn on a switch to turn on a light, you don't understand the electricity or, the mechanics behind it, the electronics behind it, but, the light just comes on and it's done for you, right? All the heavy lifting.
Oh, yes. Yeah. In fact, today you don't even turn on a switch, right? You just say, Alexa, turn on the lights.
Soon we might blink and
and after some time, I think, yeah. And the way things are moving, with artificial intelligence and all of that, I mean, at some point of time, it's probably going to be almost like, you don't even have to say anything, you probably just think it and the lights come on, or, and I don't know. I mean, it's evolving really fast, so there are things that are happening very, very fast in this space. So I think the next few years, it's going to be very interesting to see how things move.
Yeah. And then, the early days when you were sort of at these computer centers and, helping people debug, it's one thing to know, I guess, the programming language. But when you're sort of troubleshooting this, now you're getting into the sort of realm of problem solving, right? So would you say that the programming is, the basis of it, the mindset is having a problem solving capacity? And that's what you were really good at, in essence, was problem solving?
Yeah, I think that's one of my strengths, because even today, when there are, even when we have some, very complex engagements with clients, and they're stuck on a problem, people tend to sort of, call me up and say, can you come and help? And I think a part of it is more about, it's more about the thinking process, right? In the sense that it's more of, breaking it down into, what are the possibilities, thinking a little out of the box, and, really driving to the point where you can actually, identify what the root cause is. And I think that's a bit of knack that comes from experience. Of course, it does require, I would say, a large amount of knowledge. That's definitely there, because you've got to actually figure out the possibilities. Like, when something's wrong, someone says, okay, this is not working. One of the things that you've got to be able to do is, sort of arrive at, all the different hypotheses that, that sort of, say, okay, it could potentially be this or that, or so it could be A, B, C, D, E, right? And then you sort of drill down and say, okay, how do I test these hypotheses? And you start testing each of them. And then you arrive at, okay, this is, maybe D is the problem. So that does take a different, I would say a slightly different kind of thinking. And also it does take a lot of, I would say, you've got to be very, I would say, calm and collected when these kind of things happen, because a lot of times you have situations where you have a significant problem, like maybe it's a priority one incident that a client has reported, and you've got to be able to actually keep your cool about yourself, and sort of think through things logically, rather than getting muddled with the emotions that are running through at that point of time. And that's that sort of comes with experience, I guess. Yeah.
Correct. From previous lessons that you might have learned from maybe already being in a situation and building up on that, right?
Yes.
It actually reminds me of a funny acronym that I remember hearing way back, and they say the number one issue for any sort of computer related problem is BMAC, and that stands for between monitor and chair, which is the human person sitting there. Because like you're saying, you can't get mad at the computer, because it's the human that's programmed the computer. So the human is a reflection of what might be wrong, and so to sort out the problem, you have to be able to sort of maintain your calm disposition and logically look through it, right?
Yeah, that's one aspect of it. The other aspect of it also, I think, is often I mean, and this is like, I think this is a very generic sort of thinking that we have. It's not only applicable to computers or IT. Whenever you actually face a problem, the tendency is to look somewhere else, right? And you don't look at the stuff that you've done, right? So, and there's a tendency to overlook that. So, for example, let's say, okay, something's not working on my system. Maybe I have written bad code, but the tendency would be that, okay, I don't look at my code. I start going and looking elsewhere because I think my code is great, so, and I think that's, sort of a mindset thing, and you've got to be very objective when you're doing this, this kind of troubleshooting. I would say, in IT and even in life, right, to figure out whether, you're the cause of the problem or it's, really external and elsewhere, so and that's a bit challenging at times, right?
Correct.
Because we tend to think that, no, whatever I've done, it's fine. Yeah.
The spiritual gurus would say that the ego gets in the way, right?
Yeah. Yes, that's right.
What is the balance of the scientific mind versus a creative mind when you're dealing with computers and this sort of problem solving? Do you think both are equally inherent, or does it take maybe more scientific sort of binary thinking, or does it take creative thinking to sort of think laterally and think outside of the box? What are your thoughts on that?
So there are, I think both. I mean, both are applicable in the sense that, yes, there's a lot of lateral thinking involved, particularly when you're, trying to hypothesize. So when you're trying to arrive at a hypothesis, a lot of times what you're actually doing internally, and maybe sometimes even with your team, is you're just brainstorming, and at that point of time, you're not trying to judge whether, what a person's saying is right or wrong. You're just putting it down as a hypothesis, right? And then when you're actually working through the hypothesis and arriving at the sort of, root cause, at that point of time, I would say you're applying more scientific methods, and there's a sort of logical, way of approaching the problem and working through it, step by step, and seeing, okay, let's do this, and okay, it's almost like an if-then construct, right? Okay, if A is equal to B, then maybe C is equal to D, kind of, and if A is not equal to B, then maybe C is equal to F. So you sort of almost run through a sort of almost like a mental program when you're actually deep diving into each of the problem areas. But I think, yeah, it's a combination of both. And sometimes, a lot of times, when you are working through this process, because it's not that at any moment you are just applying the scientific part of your brain, or just the creative part. It's always a combination of both, because sometimes you suddenly have these aha moments, and you say, oh, okay, it's this, and it's this, because suddenly something, your intuition kicked in, right? So a lot of it is also intuitive in a sense, and I think that the intuitive part is probably a combination of knowledge and just gut feel. It's kind of hard to sort of describe it, but sometimes you just have these aha moments, and you arrive at you sort of leapfrog and arrive at a solution much earlier than you would have expected. So that kind of thing also happens. So it's a combination of both. It's kind of hard to describe. It's yeah, but yeah, it's a combination of both.
Of science and art, because I'm thinking that these people like Steve Jobs, Bill Gates, Turing, all of them, in people's eyes, they're branded as people who are maybe science majors or have that scientific thinking. But then, like you're saying, sometimes it needs that artist creative side, to sort of look at the holistic picture, right, and make that leap of faith sometimes.
Yes, and it's also a lot of it also has to do with I would say clarity of thought, and so at times, a lot of times actually, when I get into particularly hard problems, and into a troubleshooting mode, it's almost like you're in flow, right? It's like you've lost sense of time. You just very focused, and you're in flow, and essentially at that point of time, I'm not really I mean, it's almost like you don't feel anything, right? It's just your thoughts that are running through, and you're just sort of, maybe you're instructing people on what to do, or you're running commands, or you're asking people questions. And when you get into that sort of flow mode, at that point of time, that's when I think your brain is like running on steroids. It's everything's happening really fast. So when you go back and you look at it in retrospect, you're not actually able to figure out, I mean, in terms of if someone were to ask you, okay, can you go and just explain what happened during that period of time, because maybe it's just a couple of hours, but when you then try to expand that out, it seems like it's forever, that you spent trying to do it. So yeah, and I think the same thing sort of, I mean, I know, Croydon, that as a musician, it does happen to people who play music also. You just get in, and let's say you're playing a piece of music, and you get into flow, and you know what it's like, right? Sometimes you can just be playing something for an hour or two, and you don't realize, you just feel like you've been playing for 5 minutes, when you get into that zone. So
in sort of autopilot mode, and a different part of the mind is taken over, and time slows down. And
yeah.
Sure.
So, yeah.
I wanted to ask you, because you're currently a senior solutions architect, and that position of being an architect, because as we know, Bill Gates for a long time was the chief software architect of Microsoft. That was the title he used. What is the role and the position of an architect in the computer industry?
Okay, so when we look at so let me just so let me take a step back, and let's talk a bit about what we mean by architecture first, right? So when we look at architecture, we look at two different aspects of it, right? One of it is basically the structure of systems, right? What are all the different components that need to come together to deliver the functional requirements, right? So maybe, and let me take an example. Let's say you're developing an e-commerce site or something, right? You need to break this down into, okay, what are the functional requirements? And that typically comes from your clients or the person who's building the site, in terms of what he's going to sell, how does he want to sell it, Uh, he needs, and then there are some obvious things, right? And these are what we call reference architectures, right? So if I'm building an e-commerce site, I know that, okay, I need a system which is going to allow the person to upload his product catalog. It should have some search functionality. It does require a shopping cart. It does require some sort of integration with, different payment gateways or payment, banks for the payments. It does require some, sort of integration with something that can fulfill the order once it's been placed. It might, integrate with an order management system. Sometimes your e-commerce website might also have functionality which allows things like wallets. It may have some sort of CRM built into the e-commerce website. So all of this, some of it comes from reference architecture, some of it comes from client requirements. But essentially, as an architect, what you've got to do is you've got to decide what's the structure, right? So you're going to then think about this and say, okay, I need to have a component which is going to handle payments. I need to have a component which is going to handle my products, right? I'm going to have a catalog, maybe a catalog component. I have a search component. I have, a shopping cart component. So you sort of almost like you visualize this in your head, right? And then you start sort of, putting this down on paper, saying that these are all the different components. So that's the structural, the static view of what you think, is required to build the system. But then you also look at the dynamic view, which is, okay, how do these components now interact with each other, right? And that's where your client or your end user use cases come into play, right? So you'll have a use case which says, okay, the end user wants to search for an item. So how does the end user search for an item, right? So that might require interactions between the product catalog, some other functionality, or maybe a search engine or something. And you start basically modeling that. So a lot of the work that we do is actually we create models of how systems are supposed to behave, right? So there's a static aspect of it, and then there's a behavioral aspect which is driven by the user requirements. And once we have this and put this together, then we actually start handing, either we do it ourselves, we basically create additional views and additional level of detail around each of these components, or we hand it off to specialists who actually go out and build this. And this is very, very similar to, for example, what a typical building architect would do, right? He would sort of visualize what the building is going to look like, and then he would hand over, like, let's say, all the electricals to an electrician who's a specialist around, okay, how's the electricity going to flow through this building, right? And similarly, he would hand it over to someone who's an expert on the let's say the air conditioning, or someone else who's an expert in the plumbing, to in terms of designing how the water flows would flow through through that building, right? So it's very similar in nature to what a typical building architect does. So that's what architecture is per se. Now, in terms of the discipline, we always say that an architect typically should have what we call a T model, right? I mean, a T model means on the top you've got the horizontal, where we expect that, okay, it has to have a broad level of understanding of different technologies, and then the upright of the T, the vertical, is basically where it's expected that the person has at least one deep skill. Okay, and that could be the skill with which he's sort of grown up technically. So it could be like a person has worked in Java and he's come from a Java background, or a person has worked on COBOL on mainframes and come from that background, and that's sort of his deep technical expertise. And today we are actually asking for more like the pie model. So we are looking at people who have at least two areas where they have deep expertise, and then they have a more sort of general expertise across different technologies. So that's what we are typically looking for in an architect. But in terms of what an architect does today, the role is, I would say, it's almost like a 90%, I would say, communication role, and a 10% really technical role. Because besides doing all the visualization and what I spoke about initially about thinking about what the entire architecture should look like, and what are the different components, a lot of it is basically then taking that and talking to different stakeholders about what it's going to look like and how it's going to work. So it's whether it's your clients, whether it's your internal teams. A lot of time is spent around what we call taking architecture decisions. Like, for example, let's say you're building an e-commerce site. Should you host this on Microsoft Azure, or should you host it on Amazon Web Services, right? Sometimes the client might say, you decide. So how do you decide? So you've got to have those what we call architecture decisions also well documented and thought about, right? And in terms of why you are using a specific service, and what's the rationale behind it. So a lot of what an architect does is that, and that's where you go into communicating, negotiating with clients around requirements, and also trade-offs in terms of we are always trading off between things like cost and performance. If I take one example, right? So if you just think of it as, okay, you build an e-commerce website, right? And you say, okay, I'm expecting 500 users to come into this website, and you then design it based on that, right? Now what happens is that 500 users becomes 5,000. Your client tells you, okay, you want to scale this out. So you look at the architecture and say, okay, this is how I'm going to do the scaling out. So you sort of build and scale out that model. But every time you're doing that, there is a cost impact, because maybe there are more CPUs that are required, or more memory that's required, or more storage that's required. So every time you're doing that, there's a cost with impact. So a lot of times you're actually trading off. You're actually trying to negotiate with your clients and say, okay, tell me, how many concurrent users are you going to get? What is the growth of the system? How do you build it? Okay, and are you going to have a Black Friday sale, right? And are you expecting that, okay, instead of 50 concurrent users, you're going to jump to 5,000? And how do we handle those situations? So a lot of it is about communication and thinking through all these possibilities and the client requirements and all the eventualities when we build systems. So it's a very interesting role, but typically it's something that you sort of grow into. You come from a developer background, and you sort of develop your skill set over there, and then you sort of grow into this architect role.
Correct. And I guess you're saying, communication is important because it's not necessary for the architect to come from or to maybe be highly knowledgeable about, the business model of the client, right? So say, for example, if the client comes to you and says, I want to build a church, you don't have to be Catholic to sort of, build that church, but you have to communicate to the client to know what the nuances of the church are, the layout. So again, using that building model, and knowing what the capacity of the church is, etc., things like that, and trying to sort of future sense, how can this congregation grow? Do I need to build levels up, or should I things like that, right?
Yes, and that's where actually we never work in isolation, right? So typically, like from the functional aspect of things, you would have a consultant who you would be working with. So the consultant would actually be a person with deep business skills, right? He would understand the industry or the domain. Now, sometimes some of us who have been associated with a particular industry or domain, we do sort of gather that expertise as we go along, because we built multiple systems in the same domain. So we do know about those domains. But a lot of times we work with consultants who are actually the domain experts. So they actually bring that expertise on the table, and they sort of tell you, okay, this is what the business processes look like, and these are the kind of impacts that you can, sort of expect on your architecture. At the same point of time, on the other side, when you're actually, building your system, you have access to a whole bunch of specialists, right? So if there's a specific component that I'm planning on using, like let's say, a specific database, and I may not have all the expertise in terms of how to install that database, what it takes to run it, etc., right? So then I bring in a technical specialist who's very, very specialized on that, and that person provides that level of expertise. So on both sides, we do get assistance.
Correct. Okay, no, that's very interesting. And again, if we've got for programming, we've got a certain mindset for programming, then for, an architect, that also requires, another mindset, right? To be able to look at things in the present, future, and, sort of make, educational decisions based on the information you have off the variables, right?
Yes, yes, and I think one of the things that's really important to be successful as an architect is, you've just got to have this growth mindset. Because if you don't have a growth mindset, it's very, very hard, because you just, I mean, you never stop learning. It's like every day you're learning something new, and you've got to, a lot of times you've got to unlearn things that you sort of learned earlier, because technology's changed, things have moved on. So you've got to think of, also shedding some of the maybe the earlier knowledge that you'd acquired, because it's now superseded with new knowledge. So you've got to approach it with a growth mindset, and you've got to get up like every morning and say, okay, what am I going to learn today? And I think that's probably critical to being an architect, because it's a constantly moving space. The technologies keep changing. There are new things being invented all the time, and today, especially in the open source world, you have so much of um, new products getting launched almost every day that you have to keep pace. So it requires constant reading, constant learning. So that's, we spend a lot of time also doing that,
Correct.
in terms of educating ourselves.
You can't be rigid or, sort of very tunnel vision in your thinking. Or it's like water, you have to flow with it, right?
Yeah. Actually, it's very much like that. Yeah.
I wanted to ask you one last question here. Do you think, or would you recommend that, schools, and again, maybe in an elementary level or a high school level, implement a computer class as a mandatory subject? And this can be in any capacity. It could be in programming or, something else that's maybe more visually appealing, maybe, adaptable to the times. Because I remember growing up in school, it was mandatory for us to take at least one computer class. And I think I did, get some good things from it, even though I, did not pursue it as a career. But again, for maybe shaping the brain or, any thoughts on that?
Mm-hmm. Yeah, I think definitely it's a good idea, because one of the things that it does do for you is that it sort of improves your logical thinking, right? It sort of improves your logical thinking. And if you look at the way, like if you look at the way that we learned how to program, right? I mean, we didn't learn programming by sitting on a computer and writing a program. The way we learned it was, okay, here's a problem, and the first thing that we did was actually draw a flow chart. And in the process of drawing that flow chart, you actually sort of arrived at the logic that would be required to solve that problem, right? And once you actually did that flowchart, you then took that flowchart and then you wrote it in your programming language, whatever it was, whether it was BASIC or COBOL or C, C++. Today, probably you'd be using something like Python and writing it in Python. But so that whole process of taking a problem and breaking it down into a logical sequence of steps, a solution that's broken down into a sequence of steps, and then converting that into a piece of code, which you would then run and see that it solved the problem. So so I think that whole process is really important, because it sort of develops that sort of problem solving skill, that given a problem, you'd arrive at a solution through a set of logical steps. And there's a lot of logic that you apply over this. So it also hones your mathematical skills, right? Because you're actually looking at how do you apply logic to solve the problem. And one of the one of the most satisfying things of doing that, and one of the things that make it very interesting for kids in school, is that you can actually see the end result, right? So it's almost like an experiential and an experimentative way of learning, because you have a problem and you've actually arrived at a solution, and then you run your program and you actually see the solution. So that makes it very, very powerful as a way of instruction, I think.
Correct. Yeah. And as a student, like when you're sort of dealing with this problem and when you solve it, that's a boost to the the self-esteem of the person, right? That you solved this problem, you did it yourself, and you can also see the steps that you took with that that flow chart to arrive at that conclusion, right? That was successful.
Yeah, and that's, I think, very important, because a lot of times a lot of the study that we do is very theoretical, right? I mean, okay, we can talk about, quantum physics, but, you don't see it, right? You don't really, I mean, it's harder to appreciate because it's still very conceptual. But here, the advantage that you have is that, yeah, it is conceptual in a way, but then, you can also, it also translates to something that you can actually see, so that makes it very exciting.
Got it. Amazing. Listen, Michael, thank you very much for coming on the podcast. I wish you well in your career, and also hope that, the audience that's listening, those that are maybe, younger, or, even old, or, those that have kids, might be able to sort of, give computers a fair chance, right? And sort of take away some of that branding that, you have to be heavily, of scientific mind to get into it. And that it's something that, is, might be as, satisfying as the Sunday crossword, right?
Yeah, yeah, yeah. That's true. Yes. And
That's
thanks a
awesome.
lot, Croydon, for having me. And yeah, it's been a real pleasure talking to you.
No, for sure. And thanks again, and I wish you well.